Hey there everyone, Mr. Hayden here, and I'm just going to go through all of the notes except for the first page on Java's features and the thing on data types and pretty much everything that is in the document for week 1. Okay, so Java's APIs can be found online. That's the best place to go whenever you have a question about some of the methods and features that are built into Java. Every computer that is where someone's gonna be writing Java programs needs to have the Java Development Kit, which is different than the Java Virtual Machine, which computers need to run Java programs. Okay, so Java's syntax. First of all, syntax are the rules that a programming language force the programmer to follow so that any program can run. Um, Java is case sensitive, so capitalization does matter. Um, a Java program is divided into classes, and each class will have its own file with the Java .java extension, meaning, and these Java files are really just text files that you can open and edit. Um, it's a good idea to get in the habit of naming things in camel case, meaning especially variables and names of methods inside a Java program, and even a Java program itself. Um, it's a common practice programmers use. All right, this is the list of all the reserved words in Java, and these words can only be used for the specific purpose that um, they were set up to be used by the language itself. You can't name variables, um, give them these names, and these can only be used in a very specific context. We'll probably only use about half of these, and the other half we won't use at all. Okay, statements and semicolons. Almost every statement in Java ends in a semicolon, and usually they're the last line of code. Um, if you do have a conditional or while loop, you typically will not see that line of code end in a semicolon because technically the statement hasn't ended. But as far as assignment statements and variable declarations, they will always end. In fact, they must end in semicolons. Okay, curly braces are used pretty extensively in Java, and essentially curly braces divide codes into blocks. So a block of code is the code that's enclosed within an open curly brace and then a closed curly brace at the end of it. The curly braces always occur in pairs. There's never a situation where there's more than one than the other in any Java file. And the ones that match each other, the opening one and closing one, will be at the same level of indentation. All right, and these make your program easier to understand and follow because you can see it helps define the logic of it. So the rules are anytime you have an open curly brace, it's going to be on its own line of code, or at least for what we're going to be doing in here. And then after that, everything is indented inward one. And then when you're ready to close that block of code, you come back out by one level of indentation and put the closed curly brace on the same line of indentation as the opening one. So the curly braces are kind of bookends that the code on one side is above it is the same and the code below it is also the same unless of course you end in a curly brace. You know, you never indent more than one level of indentation at a time from one line to the next. So if you go all the way in, you're going to go in one at a time, and then you're going to come right back out one at a time to eventually every program the last curly brace should automatically be lining up with the first one. All right, well, we'll get into more of the structure of it. Well, just for now, know that Java classes have a class name. That name is the same as the name of the file. has to be identical, even the capitalization. So this file would have a boxbug. This class would have a boxbug file called boxbug.java. And in a Java class, everything inside the curly braces will be variable declarations, methods, constructors, and the order that these little blocks appear doesn't really make a difference. What does matter is that the curly braces are correct. Okay, so every Java program has a class that has a main method. And this is kind of a unique class. Unlike other classes, which are kind of designs for creating objects, the class with the main method is kind of like the driver or the client. It actually uses execution of a Java program begins on line 1 inside the first block, the opening curly brace of the class with the main method. So that's really where all the action happens. And in the code that goes in there, you'll be referencing other methods, variables, you're going to be instantiating objects of other classes, and so on. All right, so the comments. There's single line comments and multi-line comments, and these are used just kind of as like liner notes or footnotes that help explain to programmers what is going on in the code. In AP Computer Science, there will be a multi-line comment before every method in the free response assignments. Okay, variables and data types. There are two types of variable or data types, and Java is a strongly typed language, meaning that variables, which can be thought of as containers of information, have to have a data type, and which specifies what kind of data will be assigned to the variable. And the name of a variable is an identifier. All right, so variables can be thought of as kind of cups or places to store information. In Java, you must declare a variable before you assign it a value. And that declaration statement includes listing the data type and then listing what the identifier or the name of the variable is going to be. These declarations do end with semicolons. This is a typo here. It should be a semicolon, not a colon. They are statements in and to themselves. It is possible to both declare and assign a value to a variable on the same step. This is called initializing a variable. And the form is right here. Int x equals 4 declares a variable named x that will be assigned int values and then assigns it 4 right off the bat. Okay, so primitive data types really are just kind of pieces of information, or they're data, numbers, ints, double values, and booleans. Those are the three primary primitive data types. Ints are integers between plus and minus 208,000. Doubles are rational numbers in between 1.79, the plus or minus 1.79, blah, 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 10 to the negative 308th and 10 to the positive 308th. Boolean are just true or false, and strings, they're kind of a hybrid between a primitive data type and a object data type. But right now, all you need to know is that they are sequences of characters that are in quotation marks. Excuse me. Okay, so the basic assignment statement. So assignment statements are assigning a value to a variable, and they occur with single equal signs. So you'll have a statement, ends in a semicolon. Typically you'll have a variable name on the left, and then you'll have an equal sign, and then you'll have some kind of expression, either a numeric expression where arithmetic computations are involved. You may see some strings, you may see method calls, But all of whatever is on the right-hand side needs to be evaluated and be in the correct data type before it is assigned to whatever variable name is on the left. So it's always, you take what's on the right and you assign it to what's on the left of the equal sign. Okay, final variables are constants. So they're like ordinary variables, except that as soon as you assign a value, that's the final value that the variable can have. You can't change it, unlike regular variables. And you'll notice that you have a final variable because when they're declared, you'll see the word final. Excuse me. The other convention that you'll see is you'll see their names in all caps. Not a requirement, but that is the convention that programmers use. Okay, the order of operations in evaluating expressions in Java. This is the total list. Pretty much follows PEMDAS, except that there is no exponent symbol. You have to do the math.pow, and technically that's under the method selector. So really that does put math.pow ahead of multiplication, division, addition, and subtraction. All right. The other symbols are parentheses, which takes precedent over everything. The unary, plus plus, and minus minus, which we'll get into in just a second. Instantiation, which means creating a new object, which we'll get into later. Casting, which means converting a data type from one form to another, or a piece of information, treating one piece of information as if it were of a different data type. Modulus division, and the assignment statement itself. The assignment statement, the assignment symbol is the very lowest on the totem pole. Okay, arithmetic can be performed with literal values, actual pieces of data, numeric, of course, or final variables, or variables, the values assigned to variables. So you can reference variables in assignment statements, and the way that works is whatever value is currently assigned to that variable gets substituted, and the computation is carried out in place of, with the value in place of the variable that is listed. You need to make sure that what is on the right side of the equal sign can be assigned to the variable on the left based on its data type, and there are no exceptions. Okay, so in some ways, Java recognizes that integers are really subsets of the rational numbers, and Java will automatically promote an int value to being a double value if a double value is required. So, and it does this by tacking on 0.0. So that means if Java's, you can supply an int value when a double value is needed. So you can assign an int value to a double variable, and automatically Java will tack on 0.0 and turn the integer into something 0.0 instead of just the number itself. Now, when you're performing computations in expressions, Java goes one step at a time with looking at two numbers and a division or a mathematical operator in between. And if it sees an int and a double, then it automatically converts the int into another double, and then the answer is going to be a double. So two doubles with a mathematical operator in between, one mint, one double with a mathematical operator in between. When the computation is done, the result will be a double. So that means 5 divided by 8.0 is a legal statement expression, and it's going to be equal to 0.625. The thing you have to really be careful about is if you're doing int division in Java. And Python actually has a different symbol for int division, but in Java, it's solely based on what data types the values are that are being used when division is done. So here we have two ints and division going on with the /. So what happens is the division is accomplished, and then Java will chop off any decimal part of the quotient. Okay, so 5 divided by 8 will actually be 0. Okay, and then in this statement here, double x equals 0. Well, it's going to turn 0 after it does 0, because remember, the assignment itself is the very last thing that occurs in an operation. It would convert the 0 to being 0.0 to assign it to x. Whereas on the other hand, 5 divided by 8.0, well, that's going to be 0.625, because it's going to say, oh, one int, one double. That must mean my answer is supposed to be a double, so I'm going to just make that 5.0 divided by 8.0. The process of casting means temporarily having a data value being treated as if it were a different type of data. So, and typically this happens with ints and doubles. More commonly, well, you can do it both ways. So the way you know that you are casting, the casting is going on, is you'll have parentheses and the name of a data type inside the parentheses. All right, and then right after the parentheses, there will be some variable name or expression or math or number. Typically, right now, it'll probably be a number. And what that says is, okay, treat the number that comes right after the parentheses with the data type as that data type, the data type that's in the parentheses. So this means treat 9 as if it were a double. So that means it's going to it would convert 9 into 9.0. And then, since casting takes real precedence, if you look in the order of operations above in that list, casting's pretty high up in the list. So that means it happens in the very beginning before like any of the mathematical operations are carried out. So that means double 9 becomes 9.0. Then it does 9.0 divided by 4 and gets 2.25. 2.25 is assigned to x. If we didn't have this double here, we would have int division. 9 divided by 4 is 2. Okay, and then that's getting assigned to a double value, so it would make 2.0. Okay, so this is essentially here the equivalent of doing 9.0 divided by 4 or 9 divided by 4.0. All right, and then the last thing, if you're converting from a double, or you're casting a double value as an int, all right, you would have the word int in parentheses, and what happens is anything past the decimal point is chopped off. So if you cast 2.25 as an int, you will get 2. It will convert it into being 2. It doesn't round, it chops off or truncates. All right, modulus division. Modulus division is ordinary division, except the remainder is the answer instead of the quotient. So 6, the symbol for it is a percent symbol, and you'll hear it abbreviated the word mod. So 6 mod 5 is actually 1, because 5 goes into 6 one time with a remainder of 1. 3 goes into 8 2 times, right? 2 times 3 is 6 with a remainder of 2. 7 goes into 45 6 times with a remainder of 3. And 4 goes into 0 times with a remainder of 0. So 0 mod anything is actually 0. Okay, the unary operators plus plus and minus minus, they mean decrement and increment by 1. Plus plus means increase the value of the variable by 1. Minus minus means decrease the value of the variable by 1. I'm not going to go over this little section here. It's not in the AP curriculum, and we have enough issues to get through with such short class time, so we'll just skip it. Okay, Java's math class. So anytime you need to do some specialized scientific computations, you may need to use a method of Java's built-in math class. And you can tell math is the name of a class because it begins with a capital letter. So the ones that you'll use in this class are math.pal, math.random, math.apps, which finds the absolute value, and then math.max and math.min, which returns the greater of two values. So when you call one of these methods, the value that is computed is actually substituted back in to the assignment statement in place of that entire method call. So the result would be it would do 4.0 to the 2.0 power and get 16.0. Then 16.0 would be assigned to the double value x. Okay, you can look up all the math methods and all the useful things in the math class in Java's APIs, as I think I did in class. Okay, string concatenation. So the plus sign. So if you you can do what's called concatenate string expressions to get string literal values together by joining them with a plus sign in an expression. So in this case, this example here, this is going to create one giant string, hello John Doe, and assign it to the string variable named greeting. So that's what plus sign means in the case of two strings joined by a plus sign. However, plus also means add arithmetic values together, and believe it or not, you can have in the same expression, you can both have string concatenation and addition of numeric values. So this is a good example right here, string x equals 2 plus 2 plus 3 in quotation marks. Okay, so how does this work? Well, Java still uses PEMDAS when it goes from left to right, when it does all addition. However, in determining whether it should be doing concatenation or arithmetic addition, it checks to see what is on each side of the plus sign. If it's two numbers, one on one and one on the other, it does addition. If you have two strings, it does string concatenation. If you have one string and one numeric value, it converts the numeric value into a string. It's a string equivalency, and usually this means just putting quotation marks around it, and then does concatenation. Okay, so that means string Mr. Hayden's birthday equals 1 plus, a / plus 28 really makes a string 128, even though the 1 and the 28 are not in quotation marks, because it's going to go left to right, do, 1 is a number, / is in quotation marks, that's going to become 1 / as a string. Then it's going to do, 1 / is a string, a number is 28, it's going to make the 28 be quotation marks 28, and join them together to make a giant string. So 2 plus 2 plus 3 is going to give you 43 in quotation marks, because it's going to do the addition first of 2 plus 2, going left to right. Then it's going to have 4, a number, plus 3 in quotation marks. Well, that's going to be string concatenation, and it's going to make 43. Whereas 2 in quotation marks plus 2 plus 3 is actually going to result in 223, because as it goes from left to right, it's always going to be doing, the plus sign is always going to have a string on the left and a number on the right. So it's always going to be converting the number on the right into a string as it goes along. Now, you can't assign numeric values to string variables, so you can't just say string x equals 5. However, if you want to convert a number into a string on the fly, one trick is to do plus and then put quotation marks with nothing in the middle. So this isn't called the empty string, and Java still treats it like it was a string. So if you have a number with a plus sign and a string, that makes a string, right? Because it's treated like concatenation. So the effect is the 5 is converted into being 5 in quotation marks. There is also a way to move from a string value to parse the string and get the number that is in there. And the way you do it in Java is you call the parse double or parse int method. This isn't part of the AP curriculum, but there is a way to do it. I think if some of you may remember when we tried calculators in C#, I think it was convert.toDouble or convert.toInt. In Java, it's double.parseDouble. All right. We'll be doing a lot of command line input and output. Most of the replets will be command line input and output. And the one you really need to know in AP Computer Science is command line output. You don't technically need to know command line input because all of the code that you write will assume that the data is provided and the user is not entering it. So the way you do output is you do, on a line of code in your program, you do system.out.println, and then in parentheses, you put an expression that can either be a string, evaluated to be a string, or if it can be evaluated to be a numeric value, that's okay too. The numeric value will automatically be converted into a string and then printed. And there's both system.out.println or ln and system.out.print. Println does a line feed at the end, whereas print just keeps the cursor right after the last character that was printed, so that if you had two system.out.prints in a row, you will essentially make a single string because the second system.out.print will just pick right up right after the first one ended on the same line, whereas print line will do a line feed in between. So if you had two print lines in a row, you'd end up with 2 lines of text. All right, so there's a way to read in text and read in int and double values. We'll probably be using this in Replit. You don't actually need to, in fact, I know we are. You don't actually need to know it for the AP curriculum, but I will help you with it. However, you do need to know the escape sequences. So the escape sequences are the way that you can force a line feed right in the middle of a string, or you can force a tab right in the middle of a string that's being printed, okay, or created. So whenever you have a string literal value with \n buried within the quotation marks, \n will not be printed. What will happen is it will be as if you were hitting the enter key on your keyboard and you'll have a line feed. Whereas also if you do \t, then that is equivalent, excuse me, once again, that is the equivalent of doing of hitting the tab key. All right, so if you want to have neatly tabbed command line output, you'll have \t embedded in the strings that you will be printing. Okay, so you may say, well, if \t is, isn't treated like an actual string to be printed, how do I print \t? Let's say I do want it to be treated like a string to be printed. Okay, well, there's a workaround, and that is to put 2 backslashes instead of just 1. Okay, so whenever you have \\, that is the symbol that means print a \. Okay, so if you have a \n, that would mean print a \n B, and then in this case \t, it's going to print another \, and then tc. All right. The same goes actually for quotation marks and apostrophes and backslashes themselves, which is, I guess I just went over backslashes themselves. Quotation marks, when you're printing a string, the quotation marks enclose the string in order to actually print it. Well, if you want to print a quotation mark, then you're going to have to put \quotation mark. And likewise with a quote, quotes are used with char data, which you don't really need to know, but You may need to know that if you want an apostrophe to be printed or single quote, you have to input \quote. All right, let's see. We're almost done. Okay. Okay, so then the extended operators are plus equals, divide equals, minus equals, and times equals, and then there's even modulus, division equals. Okay, and they're kind of abbreviated ways of, instead of x equals x plus 3, programmers are all about efficiency, minimalist code, you know, x equals x plus 3. Let's count the characters. 1, 2, 3, 4, 5. Let's count the characters. X plus equals 3. 1, 2, 3, 4. So these mean the exact same thing. Increase x by 3. Make that x's new value 3 more than what it was previously. So not that important today, but years ago, of course, when computers were so underpowered and memory was scarce, every little character was a savings in memory. So programmers quickly learned to be as economic and stingy as possible with the number of characters they use. And even though it's not that important anymore because computers are immensely more powerful and can handle lengthy variable names, lengthy programs without any trouble, the programmer culture is keep things as concise as possible at all times. And the extended assignment operators are one way to do that. They're just another way of increasing something by a specific number, or dividing something by a specific number and reassigning that new value to the number. So in each of these, they're modifying the variable so that it is 3 more than what it was before. The value before is divided by 2 or multiplied by 3. Okay, and then there are basically three kinds of errors. There are syntax errors in programming, runtime errors, and logic errors. So syntax errors will prevent your program from running. Your syntax, there's something wrong about it. You didn't put a semicolon. You miscapitalized something. You forgot a curly brace. And they have to be cleaned up before your program runs. And modern IDEs, meaning the applications programmers use to write programs, will often flag you so that, put a squiggle under something that's wrong or highlight it or something along those lines. Runtime errors, on the other hand, are errors. They don't prevent the program from running, but they cause the program to stop because an instruction that doesn't make sense in the current context occurs, and Java doesn't know what to do about it. So for example, if you had a program that divided one variable by the value of another variable, well, if the one you were dividing by is 0, because of the way the user inputted numbers or your computations ended up, that wouldn't be caught at when you started to run your computer. It would be while it's running that would happen. So that would be a runtime error, and when you have a runtime error, it said that the program throws an exception. Okay, and then you can handle exceptions by writing what to do, but that's not in the Java curriculum or the AP curriculum, so we won't be getting too much into that. And then finally, our null pointer exceptions are also runtime errors. Those are creating an instance of something or trying to assign a value to an object variable without having instantiated it. But we'll get into more of that one later. And finally, logic errors. Logic errors mean the syntax is fine, but there are no runtime errors. Your program runs, but you don't get the expected results because you didn't code it correctly. So often the trickiest to figure out, and frequently just having a curly brace in the wrong spot can lead to a logic error. But sometimes logic can get pretty complicated in programs, and logic errors are hard to avoid when you're the one doing the programming, but you can figure them out usually using the debugging tools of the IDE you're using. All right, so that's all the notes that are necessary for you to do the homework and work on those Replit assignments, indent your code correctly, and then answer those other questions in that other document. So, listen to this review on tomorrow and Friday, and you can be working on the assignments before I see you on Monday. All right, have a good weekend if I don't happen to see you at school either tomorrow or Friday. Cheers.